This is Unit 2, Lesson 7. So now that we know how each of the different values can affect the transformations on our base graph, we are going to look in this note on how to actually graph those quadratic relations. And the way that we are going to learn to do this is by using something called the step method. So before we get into that, let's just first consider the graph of our base quadratic function, which is y equals x squared. So again, you should either know these points or know how to get them, which is just a matter of plugging those x values in for x using substitution. So when you do that, you should get these values here. And notice how they are symmetrical, right? We have the same numbers starting out 0, 0, going out. Those are the same values. So if I were to graph these values, that will give us a visual of our base function. Which will look something like that. Okay, so looking at this function, the question is asking us, what is the vertex? Okay, remember the vertex is the lowest or the highest point. In this case, it's our lowest point, which is 0, 0. Okay, remember it's also h comma k. We don't have an h or a k here, so we would say that h is 0 and k is 0. So either way you want to look at it, you will get a vertex at 0, 0. We can see that we are opening up, right? And that makes sense because we do not have any negative numbers out front of our x value there. Okay, now this is the new part. So it says, what is the step pattern? So the step pattern is asking us, how do you move from point to point starting from the vertex? Okay, and it's not going to matter if we go left or right. So it's asking us, starting at the vertex, how do we get to our next point? Okay, so if I go over 1, I don't know, let me use a different color. Over 1 and up 1, I get to my next point, right? So that, see how that kind of simulates a step? So over 1, up 1. And if I do that the other way too, over 1, up 1, you can see why it doesn't matter if we go left or right. Okay, so now it's asking us, okay, well, we've gone to the second point from the vertex, or the first point from the vertex. How do we get to the next one? Well, again, we're going to go over 1. This time we're going up 1, 2, 3. So we're going over 1, up 3. But how do I get to my next point? Well, again, I'm going to go over 1. This time I'm going to go up 5. Up 5. Okay, so this is something that we call the step pattern. And you'll notice if I follow that pattern that I wrote out right here, I will get to the other side too. If I go on the left, so over 1, up 1, there's a point. From that, over 1, up 3, there's my point. Over 1, up 5, there's my point. Okay, so the step pattern of our base graph, this is going to be important. You're going to need to know this, is 1, 3, 5. Okay, and that would obviously keep going, but we just need to know the first 3 steps. Okay, it's always going to be over 1, up or down a certain amount. Over 1, up and down a certain amount. So that is our base graph. Okay, so let's see what happens when we look at a different graph or a different relation. So it says, consider the quadratic relation y equals 2x minus 3 squared plus 2. Okay, so we can notice here that that has all of our parameters, right? That has an a, an h, and a k. So in order to come up with our y coordinates, just like before, what I'm going to do is I'm going to take the x it tells me and plug it into my equation. Okay, so I will write that out for a couple of them. So y equals 2, and then instead of x, I'm going to write -1 minus 3 squared plus 2. Okay, you could do that on your calculator. You will get 34. Okay, you're going to do the exact same thing with all of the other ones. You're going to replace or substitute x for the value of x it tells us. So in this case, it tells us x is 0. We would use BEDMAS here, right? We would do the brackets first. 0 minus 3 is -3. And then we would do the exponents. -3 squared is 9. Then we would do our multiplication. 9 times 2 is 18, plus 2 is 20. Okay, so maybe just make yourself a little note to keep in mind BEDMAS here. Okay, I'm not going to copy out this for all the other ones because I want to make it less jumbled. So just remember that I'm getting these y values by continuing to do what I've done in the first two here. So when I plug in 1, I get 10. When I plug in 2, I get 4. When I plug in 3, I get 2. 4, I get 4. And 5, I get 10. Okay, so let's plot these points. So again, we're not going to be able to do -1 or 0, so I'm going to start with 1. So the first point I'm going to plot is 1, 10. Second point is going to be 2, 4, 3, 2, 4, 4, and 5, 10. And again, it should always be giving you that symmetrical parabola shape. Okay, so now this is asking us the same question. So what is the vertex? We could have figured out the vertex just by looking at that equation, right? Because we know the vertex is h comma k. This is a good way to check to make sure you graphed it properly, right? So our vertex should be at 3. Remember, it's not -3 because the h is always the opposite. So it should be at 3, 2. And I look here, it is indeed at 3, 2. So we must have graphed that correctly. Okay, the direction of opening here, it's still opening up, which makes sense again because there's no negative out front of that a value. Okay, now this is the new part. So what is the step pattern? So remember, the step pattern is when we start at the vertex, we're going to go over 1 to the left or to the right and see how many we have to go up. So if I go over 1, I have to go up 2 to get to my next point. If I go over 1 again, I have to go up 6 to get to my next point. And then my next one that I don't have graphed, okay, I would have to go, my next point would be 6, 20, right? Because it has to be symmetrical. Okay, or if we went this way, it would have to be 0, 20. So to get from 10 to 20, we would have to go up another 10. Okay, so in order to determine the step pattern or to write it out when it asks you what is the step pattern, you don't have to actually write out over 1 up 2, over 1 up 6, over 1 up 10. Okay, there's a very simple way to figure out the step pattern. All you have to do is you have to take the original step pattern of the base function, which is 1, 3, 5, and multiply it by a. So it'll be 1a, 3a, 5a. Okay, so when we do that, our a value in this case is 2, right? And we can see that right there. So 1 times 2, 3 times 2, 5 times 2. When I simplify that, 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. Notice how those values are the exact same as these values here. So our step pattern is actually 2, 6, 10, and again, that would continue, right? So ... or etc. Okay, but we only really need those 3. And you will see why. That's going to help us graph, right? We don't have to waste our time anymore with this table of values as you see here. Okay, we have a simpler way to do it, so we don't actually have to worry about that. Okay, so that's the first half of the note. I'm going to pull up the second half. There we go. Okay, so now that we know what the step pattern actually is, let's look at the steps we need to take in order to graph using that step method. So the first thing we're going to have to do is identify and plot the vertex. Okay, and remember that vertex is always going to be h comma k. Step 2 is to determine the step pattern. Okay, and as I told you, that's always going to be 1 times a, 3 times a, 5 times a, 7 times a, etc. Okay, step 3 is to plot the step points. Okay, so we're going to go over 1, up or down 1a, over 1, up or down 3a. And again, that just means 3 times whatever your a value is, 5 times whatever your a value is. Okay, the next step is to reflect each point across the axis of symmetry. Right? We need to make sure it's symmetrical. We can't just use our step pattern and only go up the left side or the right side. We need to go up both. Okay, and lastly, we need to draw that parabola curve to connect those points. Okay, so let's do an example here. So it says graph each quadratic relation without using a table of values, right? The point of this is so that we don't have to use those table of values, because on that last example, when we had a, h, and k, it's a bit more tricky to go through that, right? And you have to make sure you're using BEDMAS. This is just going to be a lot easier. So the first thing is that vertex, okay? So you need to remember that when we're pulling out h, the sign is going to appear as opposite, right? So instead of +1, our h value is -1, our k value stays with the same sign, which is +6. Okay, looking at this one, in order to determine the direction of opening, we need to look, is there a negative out front? As soon as there's that negative out front, out front of the A, which we can see there, we know that we're going to be reflected, which means that we're opening down. To determine the step pattern, remember, you're taking that original, which is 1, 3, 5, etc., and multiplying it by your A value. So in this case, we're multiplying by that -3. So we have 1 times -3, 3 times -3, 5 times -3. Okay, and we would fully simplify that. So 1 times -3 is -3, 3 times -3 is -9, 5 times -3 is -15. Okay, so again, we're following these steps here. So we had to identify the vertex, figure out the step pattern. Now we need to plot our points. Okay, so I am going to plot my vertex, which is -1, +6. Now I'm going to use my step pattern to find my next points. So remember, the step pattern is always over 1 and then up or down the amount. So this one we know is going down because it's opening down. We also know that it's going down because we have negative numbers here. Okay, so we're going over 1, down 3. 1, 2, 3. Plot a point. Over 1, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I can't go any further on that side. This is where I need to plot those points exactly symmetrical on the other side. Okay, so I can either use symmetry to do that, right, by just looking at those points, or I can simply use my step pattern on the other side. So I can go over 1 to the left now, down 3. From there, over 1, down 9. Okay, and then the last step is simply to connect those dots to form, whoops, oh my goodness, form your parabola shape, which hopefully will look a little bit better than mine. Okay, so that is how we use the step pattern to graph these functions. So let's do one more example here. So again, it's asking us, what is your vertex? We know our vertex is HK, where H appears as the opposite sign. So instead of -3, I would write +3, and K will stay the same. To determine if it's opening up or down, we're just looking, is there a negative out front? There's not, so we have it opening up. Okay, the step pattern, remember, is 1 times A, 3 times A, 5 times A. So we have 1 times 1/2, which gives us a half. We have 3 times a half, which gives us 1.5. And we have 5 times a half, which gives us 2.5. Okay, so we are going to plot our points using that information. So the first thing that we need to do is plot our vertex. So our vertex is at positive 3 on our x, negative 2 on our y. Okay, so it's going to be there. Now we're using our step pattern to find our next point. So it's telling us, our step pattern tells us over 1, up a half. So somewhere between there. Okay, over 1, up 1.5. Over 1, up 2.5. 1, 2.5. Okay, and again, we're going to do the same thing on the other side. Over 1, up a half. Over 1 from there, up 1.5. So that is, did I plot that right? No. 1. Oh yeah, 1.5. Yep, I did. 1.5. And then over 1, up 2.5. So 1, 2.5. Okay, and the last step is to connect those dots. Whoops, with your parabola shape, which will look something like that. Okay, so not only now do you understand the transformations, you should also understand how to graph using the step pattern. Okay, so one last piece of our note here, it's just asking us to complete the table. So this is just kind of a little bit of a summary. So again, the vertex, that should be review from the last lesson. That's always going to be HK. So for this equation, that would be 2, 1. My step pattern, because I have nothing out front, my step pattern remains the same as my base function, which is just simply 1, 3, 5. Okay, and lastly, the direction of opening, it's always going to be up unless there's a negative number there. So this one is up because there's no negative. Looking at our next equation, our vertex, again, make sure your h is appearing as opposite. So that positive 4 is going to become negative 4. Our k value is 64. Okay, our step pattern here, we're taking that original step pattern and multiplying by negative 4. So I'd have negative 4, negative 12, negative 20. And because I have that negative out front, I know right away I'm opening down. Okay, so if we have the vertex, the step pattern, and the direction of opening, we can actually come up with the equation. Okay, so as soon as we know that the direction of opening is down, we know that we have to have a negative out front. Okay, we know that we just have negative 1 as our a value because if we look at that step pattern, it's not being multiplied by anything, right? It was just multiplied by negative 1. So our a value has to be negative 1. To come up with our h, remember our vertex is just h comma k. So our h is positive 20, which means we have to make it appear as the opposite. So minus 20 squared, and our k value is negative 10. So just simply by having the information of the vertex, the step pattern, and the direction of opening, we can create that equation. So this is the end of the note on using the step method to graph quadratic functions.